Friends, this is the second question of 2023 free response questions. Here, this is a cart. It is sliding down an inclined plane, and the coordinate axis is such that this direction here is taken as positive x direction. Along the incline, down the incline has been taken as positive x direction. So the acceleration a of the cart in that direction is taken to be a. It is released from rest at top of the ramp, okay, at t is equal to 0. Moves down, obviously, and x-axis is defined parallel to the ramp, okay. So this is the plus x-axis, okay, along the incline. The student collect the data shown in the table here. Now the question says, indicate which quantities could be graphed to yield a straight line whose slope could be used to determine the acceleration A of the cart. You may use the remaining columns in the table to record the. We have to, find the acceleration of the cart down this inclined plane. The position and the time data has been given. Okay. So what else do I need here? I know that by the equation of motion, S, that is the displacement, is given by U times T plus half a t square. This is the displacement, S is the displacement, right? U is the initial velocity, T is the time, A is the acceleration here. Now, since the block is starting, the cart is starting from rest, the initial velocity U is going to be 0. This thing here is 0. That means the displacement of the cart can be given as half times acceleration times time square. Now it is starting from the x is equal to 0 position here. So whatever is the displacement is the position. So it is given at t is equal to this time, this is the position. At this time, this is the position. And likewise, I have been given a table of time and position. I need a straight line graph. I know that a graph y is equal to m times x. A graph like this, where m is the slope of the graph. It is a graph passing through the origin like this with a slope m. Okay, if this is the y-axis, this is the x-axis. Y is equal to mx is a line like this, where m decides the inclination is the slope of the line. Right. So if I need a straight line graph, okay, this is for this situation, I can say x is equal to half times a t square. I want a straight line, okay, a graph like this. What I'll do, x is equal to a, I will make as the slope. A, I will make as the slope half t square. This thing I'll treat as my independent variable. So x is equal to this. So this is the dependent variable, and half t square I'll treat as the independent variable. So like, this y, x acts as this y, and the dependent variable x is half t square. So the quantity here will be half t square. So you see, this is y is equal to, this is like slope, y is equal to m times x. That form it is taking. Time is given, I will write the values of half t square. With half t square, with this as the independent variable, this will give me, this thing will give me a straight line graph passing through the origin. So for 0.39, this is going to be 0.7405. For t is equal to 0.59, this is 0.174. This is 0.296. Okay, obviously there is a 0. This is 0.46, and this is 0.72. 0.072. 0.7405 or approximately 0.07. These are the values of half t square for the given time. Now you see, if I will try to make a graph of position on the y-axis, that is x, okay, this position, and here on the x-axis I'll mark half t square. I'll get a straight line graph passing through the origin with slope as the acceleration. The acceleration will be the slope of such a graph where half at square I am plotting on the x-axis and the position x is on the y-axis here. So that answers the first part of the question here, right? So that answers the first part of the question here. I have to plot half at square on the x-axis and the position, that is x on the y-axis. It will give me a straight line graph passing through the origin with slope as the acceleration. The acceleration is the slope of such a line. Okay. This is evident from here. This thing. A is the slope, half at square is the independent variable. Okay. I can tabulate the values here. Plot this on the y-axis, this on the x-axis to get this.